acid chlorides and acid anhydrides and their reactions. Acid chlorides are one of the carboxylic acid derivatives. They have the functional group COCl, so replacing the OH of the carboxylic acid group with a chloride. They are more reactive than the carboxylic acid themselves. This is because of the presence of the chloride, which withdraw the electron density from the carbonyl functional group. To name acid chloride, we name them by replacing the suffix "ic" with "yl" for halide. So, for example, if we have something like benzoic acid and we make the acid chloride, where we replace the OH with Cl, this is called benzoyl chloride. And then we have we can also name acid chlorides which have different substituents like this acid chloride. To name this one, you need to number the carbon chain, which is 1, 2, 3, 4, and 5. So this is bentoyl chloride. And then we have an OH carbon number 3, so 3-hydroxy, and we have methyl group and carbon number 2, so this is 2-methyl. So the full name is 4-hydroxy 2-methyl bentanoyl chloride. Acid chloride reactions. Acid chlorides would react with different nucleophile where the chloride is eliminated in this reaction and it's substituted with the nucleophile. So for example, with water, they have vigorous reaction at room temperature and they give the acid itself and fumes of hydrochloric acid. For example, if we have something like ethanoyl chloride reacts with water, that will give you ethanoic acid and hydrogen chloride. Here we replaced or substituted the chloride with an OH from the water, and the other hydrogen from water reacted with the chloride to give you hydrogen chloride. With alcohol, they have a vigorous reaction as well at room temperature, and that will give you the ester and hydrogen chloride. So if you have ethanoyl chloride, it reacts with methanol to give you methyl ethanoate and hydrogen chloride. This is again another substitution reaction where you have or the ester, the alcohol has substituted the chloride and the chloride has left. So this reaction is similar to the reaction of carboxylic acid with an alcohol to give you the ester. However, this is better than reacting the ester with the acid itself, reacting the alcohol with the acid itself, because here the reaction is irreversible and it doesn't need a hydrogen catalysis as well. So it's better than the other reaction and it gives you the same product, which is the ester. Also, acid chloride can react with ammonia. The reaction will proceed violently at room temperature, and that will give you the amide. The amide is one of the carboxylic acid derivatives as well, where we replace the OH of the acid with an NH2. This is called amide. So for example, if we have ethanoyl chloride reacts with ammonia, that will give us the ethanamide and hydrogen chloride as well. And finally, with primary amines, they also react violently at room temperature, and in this time, they will give in substituted amides. So, for example, if we have ethanoyl chloride reacting with a primary amine like methylamine, the another substitution here that will give you N-methyl ethanamide. So, N-methyl because we have the methyl group on the nitrogen and hydrogen chloride as a side product as well. So this is a summary of the different reactions of acyl chloride. So with water, we call this hydrolysis. The nucleophile here is water. The product is carboxylic acid with hydrogen chloride. With ammonia, we call this aminolysis. So that will give you the amide and HCl, which can react with excess ammonia if we have to give you ammonium chloride. And then with alcohol, it reacts, the nucleophile here is an alcohol that will give you the ester and hydrogen chloride. Acid anhydrides are another type of carboxylic acid derivatives, and they are similar to acid chloride in terms of reaction. So what are acid anhydrides? When two molecules of acids combine together with a loss of water, they give you what we call the acid anhydride. So we have two molecules of acid and they lose one molecule of water with one OH from one carboxylic acid and a hydrogen from the other one. That will give you the anhydride. The anhydride here will have two carbonyl group with an oxygen linking these two, and then the two R groups, which are the rest of the carbon chain. Anhydrides, again, as I said, they are another type of acid derivatives like acid chloride, and they are more reactive than the acids themselves, but they are less reactive than the acid chloride or the acyl chloride. To name an anhydride, you simply replace the word acid from the acid name with anhydride. So if we have something like that, this is an acid anhydride that is made from two molecules of ethanoic acid. So to name this one, we simply replace the acid from ethanoic acid and replace it with anhydride. So this is called ethanoic anhydride. Acid anhydrides react in the same way as the acid chloride. So, but they have an advantage over the reaction of acid chloride that the reaction is less violent, and also the reaction with acid anhydride does not produce the fumes of HCl, which are quite toxic fumes. So, for example, if we have ethanoic anhydride and react this with an alcohol, that will give you the ester, which is the methyl ethanoate, and the other product is going to be the carboxylic acid itself, which is the ethanoic acid. So one of these two is going to be replaced. So the leaving group here is going to be ethanoic acid, and then we have this nucleophile, which is going to be added to this carbonyl carbon. So the two products here are methyl ethanoate, which is the ester, and the other part which has left, which is ethanoic acid. So this is a summary of the reaction of the acid anhydrides with different nucleophiles. So with water, that will give you two carboxylic acids. When the anhydride has the same, comes from the same carboxylic acid, then you have only one product of only one carboxylic acid. And then with ammonia, that will give you an amide and will give you the carboxylic acid, which can react with the ammonia to give you the salt, the ammonium salt. And then with an alcohol, as we've seen, they will give you ester and will give you a carboxylic acid. So the general reaction, the mechanism for these types of reaction, whether we are talking about acid chloride or we are talking about acid anhydride, has two steps. The first step is an addition and the second step is elimination. So first step here is the addition step where you have the nucleophile. The nucleophile could be water, could be an alcohol, or it could be an ammonia, or it could be an amine, so RNH2. Any of these nucleophiles will first be attacking this carbonyl carbon because the carbonyl carbon is partially positive. It has a low electron density because it's attached to the oxygen and the leaving group here, which could be a chloride, or it could be the other part of the ester of the acid if it's the anhydride, and these two will withdraw the electrons or will pull the electrons away from the carbon, so the carbon will be electron deficient, and then the nucleophile can attack. That will open the double bond between the oxygen and the carbon and will give you a tetrahedral intermediate where the nitrogen, the nucleophile has been added, and then the double bond has been removed. The second step is the elimination, where the oxygen will again replace, where again make the double bond between the oxygen and the carbon, and then we have the chloride or the other part of the acid in case of the anhydride will be leaving here. So this is the elimination step, and then you will end up with your substitution, the final substitution product, and then we have the leaving group, which could be the chloride that can react with hydrogen to give you hydrogen chloride, or it could be the acid in case of the anhydride. So now The nucleophile, these are the different nucleophiles, and these are the different products. So if we have water, the product will be an acid. If we have an alcohol, the product will be an ester. If we have an amine, a primary amine, or if we have ammonia, the product will be an amide. So let's see the reaction mechanism in more details now. So let's say that we have a reaction between ethanyl chloride and methanol. So the first step is that the oxygen of the nucleophile of the alcohol will attack this electron deficient carbonyl carbon, and the two electrons of the double bond between the carbon and oxygen will go towards the oxygen. Then you will end up here with the tetrahedral intermediate, with the oxygen having a negative charge here because of these two electrons which move to the oxygen, and the alcohol that has been added. Now the oxygen has a positive charge because it still has the hydrogen and the methyl attached to them. The next step then is going to be the elimination, where the chloride will be eliminated, and then the oxygen will push the electrons back towards the carbon to make the double bond. So now you have your second intermediate where the chloride has left completely or eliminated. Now we have this chloride and we have the alcohol part where there is a positive charge on the oxygen. So the chloride will abstract the hydrogen from this alcohol, and then we will end up with the final products, which are the ester and the hydrochloric acid as a side product of this reaction. The reaction mechanism is going to be exactly the same, whatever the nucleophile you are going to use. So if you have water, then instead of having CH3 here, you're going to have another hydrogen, but the reaction will proceed exactly the same, and the product is going to be an acid. And it's also the same reaction mechanism if you use an anhydride, where the leaving group in this case, so if we have an anhydride, let's say we started the reaction with the anhydride, so ethanoic anhydride like this one, and then you have the methanol CH3OH. So the first step again is going to be this one attacking this carbonyl carbon, and this will give you the intermediate, which is going to be CH3C, and then the O with the negative charge, and then the OCO CH3, and then you're going to have your alcohol, which was added in here. This oxygen will have a positive charge. And then the next step, which is going to be the elimination step, and then this is going to leave here, and then the double bond will be regained. And then you're going to have the carboxylic acid salt, or the carboxylic acid with the negative charge, which will then come to abstract the hydrogen from the methanol. The final products are going to be the carboxylic acid, which is the ethanoic acid, and will be the ester in the same way, which is going to be methyl ethanoate. Ethanoic anhydride is used for the manufacture of aspirin. So aspirin is an ester, carboxylic is an ester, and its ethanoic anhydride is used to make that ester. It's an ester of salicylic acid. So we have salicylic acid, which is have an OH, has an alcohol, and has a carboxylic acid functional group as well. If you react this alcohol or this carboxylic acid, which has an alcohol functional group, with ethanoic anhydride, this reaction will proceed to make the ester. So it's an ester of salicylic acid. This is called aspirin. And then you're going to have a side product of ethanoic acid. We can use either the ethanyl chloride or acid ethanoic anhydride to make the to make aspirin. However, ethanoic anhydride is preferred over ethanyl chloride for several reasons. First of all, it's cheaper than ethanyl chloride. It's also safer because it's less corrosive than ethanyl chloride, and it reacts slowly, more slowly with the alcohol than the acid chloride. And finally, it doesn't produce the dangerous hydrogen chloride fumes which are produced when we react the acid chloride or ethanoyl chloride with the alcohol.